Let's see. For that, I mean, you could make an area graph. Small examples. Area graph for probability for a certain thing.
Yeah, so here, look, it says starts at 0 on the number line and makes a sequence of jumps. In any one jump, independent of previous jumps, Laura leaps a positive integer distance and with probability this. What's the probability that you eventually land at? Okay, so let's consider 0. It's the first. What's the probability to get here?
Uh, 1.
Yes, good. Now let's consider this. What's the probability to go to 1?
1/2.
Yes, because of the probability of this is 1. The length is 2, so it's 1/2. So the question mark is 1/2. Good. What about this one?
That would be 1/4.
Let's check. We should consider step by step. What's the probability to jump from here to here?
Oh, I see. Okay, now it starts to be casework. That would be 1/4, and that would also be 3/4.
So let's check. 1/4 because of this, 1/2. So the probability for this is 1 times 1/4 plus 1/2 times 1/2. Which is what?
Oh, I see. And then okay. That would be 1/2.
Exactly. So this one is 1/2. Now let's consider the next one, the third thing. Calculate 3.
It would be 3, right?
No. Do you need a hint or want to try it again?
Yeah, it's like if I try it again. So it'd also be 1/2?
Exactly. Because if we start from here, it's 1 times what? Tell me to write.
From 0 to 3, it would be 1 times 1/8.
1/4 plus, what about this?
From 1 to 3, wait, sorry. Do you mean from 0 to 2 or 0 to 3?
0 to 3, sorry, it says 0 to 3 is 1 times 1. What about this one?
1/2 times 1/4.
What about the next?
1/2 times 1/2.
Exactly. So it would be 1/8 plus 1/8 plus 1/4. 1/8 plus 1/8 is 1/4 plus 1/4, which is 1, right? Okay, can you guess what the answer is?
1/2.
Yeah, so let's prove it. Suppose, for example, until n minus 1, we proved 1/2. Now we want to prove for n is 1/2 as well, okay?
Okay.
Okay, try to prove it for n. Suppose that we know all these things are 1/2 and this one is 1. We want to prove for n is 1/2. Try.
Okay. Is it okay if I state what I did so far and then I see how to improve? Okay, so I wrote out 1 times 1 over 2n.
Exactly. What about the next one?
Plus 1/2 times 1 over 2n minus 1.
What about the next one?
1/2 times 1 over 2 to the n minus 2.
Exactly. Then what?
And then it would end at 1/2 times 1 over 2 to the first, and then plus 1/2 times. Wait, no, what that?
1/2 times 1/2, right?
Yeah.
Yes. Then what?
Then I took out the 1/2. So I left the 1 over 2n by itself, but I took out a 1/2 from the rest of the sequence.
Yes, but do you agree we can say it's 1 over 2 to the n plus 1 over 2 to the n plus 1 over 2 to the n minus 1 plus 1 over 2 to the n minus 2 all the way to 1 over 8 plus 1 over 4?
Yeah.
Okay, what's this one equal to?
So that would combine into 2. 1 over 2 to the n minus 1.
Good job.
I see.
What's the sum
Okay.
of these two?
1 over 2 to the n minus 2.
What about these two?
N minus 3. 1 over 2 to the n minus 3.
What about these two?
Since we're combining 1/2.
Exactly. Finished, right? It is
Yeah,
a solution.
it's
If you want, you can state your solution so I can find it. Want to state your solution?
Yeah, I was trying to use the r1 minus r to the n plus 1
Yes,
over
okay.
1
With
minus.
that way, we can reach the same answer. So can you explain?
So after I took out the 1/2 from everything but the first term, I then used. I'm not sure if I could do this, but I used the a over 1 minus r formula, but that just gave me 1, and then I was confused
Let
on
me
what
check.
to
You
do
use
next.
what formula?
A over 1 minus r, or 1/2
No,
over 1
That
minus
one
1.
is for the case that, look, a over 1 minus r is for this one. A-A-R. For when absolute value of r is less than 1 and it is all the way to infinity. Then it is a over 1
I
minus.
see.
If you have a
So
plus
just
ar all the way to ar to the end, what would it be?
1 minus r to the n plus 1.
You have a, and you can factor from a, and 1 minus r, right?
Yes.
Okay, now use this formula, the new formula, to prove it is 1/2 correct.
Okay, I see. Also, so basically n would not be the equivalent of infinity in most cases, unless
Eh,
specified.
Yes, in some cases it is infinity all the way, you should use this. In some cases it is all the way to, for example, a special number, then you should use this. It depends on the problem. Okay, try.
I think this is also where I get stuck. I got 1 minus 1/2 to the nth over 4 plus 1/2 1 over 2 to the n. But
So if you
I'm not
factor from
sure.
1/2, look, we know that 1 plus r to the n is r1 minus r to the n plus 1 over 1 minus r, right? So if you
Yes.
factor from 1/2, it would be 1 plus 1/2 all the way to 1/2 to the power of what?
It would be 1/2 2 to the n minus 2.
Exactly. So what's this one equal to?
That one would be equal to 1/2. Sorry, no, I mean 1 minus 1 to the 2 n minus 1. Yeah. Thanks.
Minus 1/2, right? 1 minus 1/2
Yes.
and this one will cancel each other out, right?
Wait.
If you want, let me write it again. It's 1 over 2 to the n plus 1/2 times 1/2 times 1 minus 1 over 2 to the n minus 1. 1 minus 1/2 is 1/2. Agreed?
Yes.
Now do you agree these two cancel each other?
But wouldn't, if you multiply
in the denominators, it is the numerator it is
1/2 times. Oh, I see. Yeah, sorry, I got confused. Okay.
Okay, so it's 1 over 2 to the n plus 1/2 times 1 minus 1 over 2 to the n minus 1, right?
Yes, so that would. Oh, okay, that'll just leave 1/2.
1 over 2 to the n plus 1/2 minus 1 over 2.
Okay,
You
I
cancel
forgot to take.
these two terms, so it would be 1, right?
Yeah, I see. I forgot to take it. 1/2.
Okay.
Thank you.
So